All right, so today we're going to be talking about distance formula. Yesterday we talked about the Pythagorean theorem, so we're going to kind of go ahead and try this out using the Pythagorean theorem. We have the points at 2 comma positive 1, so 1, 2, positive 1. Okay, let's call that our first point, A. And then our second point B would be at 3 comma negative 7. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay. And we'll call that B. And we want to find this distance. Okay. So using the Pythagorean theorem part, right, we got to count to find our two legs because the distance between A and B is our hypotenuse. So we got 1, 2, 3, 4, 5, 6, 7, 8, right? So that leg right there for that right triangle is going to be 8 units, right? And then we have 1, so that leg's going to be 1 unit. Okay, so those are our two legs. Okay, and this is going to be C, our hypotenuse, because that's our 90-degree angle, and that's what we're going to be looking for. So we can call this one A, we can call this one B, and we can now set up our Pythagorean theorem. Okay, so 8 squared plus 1 squared equals C squared. Okay, and then this is what we did yesterday, so it should be fairly easy. Okay, 8 squared is 64. 1 squared is 1. This is equal to C squared. So we have the square root of, we'll have 65 equals C squared. Okay, all right. And then once you do that, you got to take the square root, right? Because we're solving for C. So we take the square root. Oops, sorry. Okay, and then the square root of 65 is approximately 8.0622 or 23, I guess. Depending on how your teacher wants you to round it, you could round a couple of ways. So just in case yesterday we didn't get to touch up on rounding very much, um, let's say that we wanted to round to the tenths place. Well, we go 1, 2, and this 6 tells the 0 what to do. If it's greater than 5, greater than or equal to 5, it goes up. So it would be a 1. If we round to the tenths place, we would go 3 places, and then this 2 would tell that 6 to do. So either your answer can be 8.1 or 8.06, depending on how you want to round. This right here is to the tenths. This right here is to the hundreds, right? To the two decimal places. Okay, so just in case, depending on how your teacher wants you to round it, that's how the distance could possibly be. Okay, so now we have this special formula called the distance formula. Distance formula is very helpful. Just in case you don't have a graph or you have stuff like this where you got to count a lot, like really long, right? Sometimes the distance will be really far. So you can use this distance formula to help you solve for it instead of using the Pythagorean theorem. So the first thing you want to do is label your points. Super duper important. So when I say label, you're going to take this one, which we'll call, point 1, if you will, and we'll label it x1, y1. X1, y1, those stands for the x value of the first point, y value of the first point. That's why you have that little subset right there. And then this will be x2, y2. Okay? So now that we have labeled, now we substitute our points in this distance formula, right? So our distance is equal to the square root of, right? X2 minus x1. So x2 is negative 6, x1 is 0. So negative 6 minus 0 squared plus y2, which is 2, minus y1, which is 4 squared. Okay, so be careful with this. We're going to go step by step on this. Okay, negative 6 minus 0 is negative 6 squared. Now make sure you're using parentheses when you type this in your calculator. 2 minus 4 is negative 2 squared, and we're going to take the square root of that. Make sure you use parentheses, because you don't use parentheses, it's going to give you a negative value, and all these things are going to mess up. So make sure you use your parentheses. Okay, negative 6 squared is a positive 36 plus negative 2 squared is a positive 4. Yes, believe it or not, when you square a negative, you get a positive number. So this becomes the square root of 40. And later on, we'll learn how to simplify radicals where you don't get decimals. But for this particular purpose, we're going to go ahead and take the square root, right, of 40, and that's going to be equal to 6.32. And I'm just going to round to the tenths. So your distance is equal to 6.32 units. Okay? That's how it is afar from point 1 to point 2, right? X1, Y1, X2, Y2. That's why it's so important for you guys to make sure you label. Okay, labeling is super important. Okay, we'll do the next one as well. Get a couple of practice plays, right? X1, Y1, X2, Y2. Okay, use those parentheses. Distance is equal to the square root of x2, which is 0, minus x1, which is negative 8, squared, plus y2, which is negative 3, minus y1, which is 6, squared. Okay? 0 minus negative 8 is a positive 8, so that's positive 8 squared. Negative 3 minus 6 is a negative 9, so that's a negative 9 squared. Make sure you're using your parentheses, right? Now, what's important to note, you see this right here? This right here is going to be your horizontal distance. We kind of touched on that yesterday. And this right here is going to be your vertical distance. So that's like counting this right here would be our vertical, and then this right here would be our horizontal, right? So that's kind of how we touched up on that yesterday. And that's why it's always positive, right? Length's always positive. Okay. So this is why these outcomes are going to be positive 64 and 81, right? That's why those outcomes are positive, just in case you were wondering. Okay, so that gives me the square root of 145, which, again, I'm going to round to the nearest tenth, is going to be 12.04. Okay, pretty easy stuff, right? Okay, so just continue doing that. Let's do one more, I guess. Um, I'll skip that one and we'll do this one right here. Again, we'll label x1, y1, and x2, y2. Okay, so my distance is equal to the square root of x2, which is negative 7, minus x1, which is negative 8, squared, plus y2, which is negative 1, minus y1, which is negative 2. Okay, so again, just in case, this is your distance formula, just in case. Don't forget this. Oh, that red's probably, I'll use black. Okay, so square plus y2 minus y1. Now, it does have to be in order like this, y2 minus y1 and x2 minus x1. It does have to be in that order. So make sure that you guys are aware of that. Okay, so negative 7 minus negative 8, that's going to give me a positive 1. Okay, and that's positive 1 squared plus 1 minus negative 2, that's going to give me a positive 1 again, because you want to do a change with these. Okay, 1 squared plus 1 squared is 2. So this is really the square root of 2. And you can actually use that as your answer, but that's not what we want to do. Okay, so my distance is approximately 1.41. Okay, now you can practice using the Pythagorean theorem on this piece. Okay, you got 5 comma negative 5, so 1 2 3 4 5, 1 2 3 4 5. So that's 5 comma negative 5. We'll call that 0.1. And then you have 4 comma negative 4. 1 2 3 4, 1 2 3 4. Well, I don't know why we would do 5 negative 5, 4 negative 4. I mean, that makes a very, very small right triangle. um, that's a very short distance. Let me make sure I didn't see. Oh, I did not read that wrong. Okay, so Pythagorean theorem, right? This leg's 1, this leg's 1, right? So we have 1 as your A, right? So our legs A is equal to 1 and B is equal to 1. We want to find our C because that's our distance. So 1 squared plus 1 squared equals c squared, right? 1 plus 1 equals c squared. That's 2. And if I take the square root, c is equal to the square root of 2. And this is actually a special triangle, special right triangle. Notice the legs are exactly the same, and my outcome is a square root of 2. We are going to touch up on that later on this year. Okay? So if you guys have any questions, please feel free to reach out and let me know. Thank you.